Welcome back to my channel. In this video tutorial, we are going to focus on transforming logic circuit diagram into logical function. How to write a certain circuit diagram in terms of a function. So let's begin with an example. We are going to go over tons of examples so you can master the steps and the process of writing a circuit diagram in terms of a function. So let's begin with number one. This is a circuit diagram ahead of us, before us, that we need to solve. So what should we do? All you need to know is that here's where we are coming. This is our destination. This is Z. Z is the output. So how can we get Z? You can start from anywhere, but you always start from the upper part. Now you can see that this gate right here is an AND gate. And according to AND gate, whatever inputs that is being inserted into the AND gate, those inputs are going to multiply one another. So therefore, for this input, let's assume the output is X, and for this, the output is Y. So therefore, X will be equals to A times B times C. And for Y, Y will also be equals to D times E. Now it turns out that it is X that tends to come all over to come and meet the logic gate Z. Okay, you can see. And also Y also tends to go to the logic gate Z. And eventually it is observed that logic gate Z is also an AND gate. And according to the AND gate, the inputs are going to be multiplying each other. So therefore Z is going to be equals to X times Y. And X is ABC. So finally Z will be equals to ABC times D E. And final answer is A, B, C, D, E. And this is the output for this problem. Number two, how can we find the final output of this problem? So assuming this is Z. So let's begin. So first, let's assume this is X. And the output here, it comes all the way to Z direct, so it's not connected to anything. So it turns out that X is going to be equals to A bar. You can see that the gate that connects A is a NOT gate, and according to NOT gate, the input is going to be negated before the output is going to be produced. So therefore, X will be equals to A bar. Now it turns out that the A bar, the B, and the C tends to form the output Z, and they are formed by the logic gate AND gate. So therefore, they are going to be multiplying each other. So Z will finally be equals to A bar times B times C, and which is simply A bar B C. And this is the final answer as the logical function of the diagram as well. You can see how I'm combining those inputs together. You just need to be taking them one after the other. Don't be confused and don't be carried away. Let's go over more problems for better understanding. Number three, let's provide the output for this problem. So assuming this is the output Z, how can we have the value of Z in terms of RST XYZ? Now, in this case, the logic gate is different compared to the one we have been dealing with in the previous examples. You can see that this gate is simply the OR gate. Okay, they are both the OR gates. So therefore, according to the OR gate, the inputs that is received are going to be added to provide the output. So if this is X and this is Y, so definitely X will be indeed equals to R plus S plus T. And similarly, Y will also be equals to, why should I use Y? Let me use something else, because among the inputs I have Y. Let me use R. So R is going to be equals to X plus Y plus Z. Perfect. Now it turns out that Z is formed by an AND gate. And according to AND gate, the inputs are going to multiply each other to provide the output. And we can see that the input that is received by the AND gate Z is simply X and Y. And therefore, Z will simply be equals to X times y. And x, let's substitute as we have. X is r plus s plus t, r plus s plus t, and y, oh sorry, r rather, I later use y. Oh, that's my bad. X plus y plus z. Okay, so instead of having y here, it's simply r. Okay, that's r. All right, and here as well, simply r because we used r. Okay, as the r, we used r. So hopefully you grab that. So that's just the final solution, the output of z. If you want, you can expand. If you don't want, you can leave it the way the answer is still pretty much okay. Okay, you can, I believe you are getting the process, you are getting the steps in which I'm taking those values one after the other. The main thing is just to master the gate. Make sure you know that once you see this gate, this circuit diagram, you should know what it usually is to do to produce the output. This is to add the input, or does it use to multiply the input? Does it use to negate the input before it produces the output? And so it's something you want to make sure you keep in mind. All right, another example, number 4. I think this seems somehow tricky. However, it's something we can handle. So let's begin with D. We're going to produce the outcome for D. Okay, outcome for E. Then finally, we get outcome for Q. So first, we can see D. What kind of logical gate is D? Now we can see that it is an OR gate. However, it is being negated. Therefore, it is a NOR gate. That is all followed by negation. So therefore, D will simply be equals to A plus B. But due to the fact that we have a little circle over here showing that the result has to be negated, then there's going to be a negation above A plus B. And this is the outcome for D. Now, what about E? It turns out that E is simply an AND gate, a single AND gate. And according to the AND gate, the inputs are going to multiply each other. So what are the inputs that came to make E? It turns out that it's just B and C. And therefore, E will simply be equals to B, C. Now, having gotten this, we can now get the value of Q, which is the final output. It is observed that the logic gate of Q is an OR gate, and we know that according to OR gate, the inputs being received are going to be added to produce the output. And it's observed that the input is simply D and E, and therefore Q will simply be equals to D plus E. So let's substitute the values respectively. D is the negation of A plus B, and E is simply BC. And this is the final output. If you want, you can simplify. It's pretty much okay. If you don't simplify, it's still perfect. According to De Morgan's law of logic gate, the sum of complements can be replaced with the product of complements, and that would be A bar times B bar plus BC. So this is the final solution to this problem. So that's simply the value or the outcome of Q. By now, you should have been very perfect in expressing logic circuit in terms of function. One more example for this problem, which is quite more complicated in this case, and I believe you should be able to handle that. Feel free to pause the video and check this question out. Provide the solution, the final output Z to this problem. Alright, let's begin. First, we can see that we are having 3 different gates that makes up the final gate. So the first gate is an AND gate, assuming it is simply, let me use, okay, I want to use a certain letter. I know that was coming to my mind. Okay, let me just use C, D, and E. Okay, so C is formed by an AND gate. So therefore, the inputs are going to be multiplied. So C is indeed equals to A times B. D is formed by an OR gate, so therefore the inputs are going to be added. That's M plus N. And finally, E is formed by a NOR gate, that is OR gate followed by a negation. So E will simply be equal to the OR gate, which is X plus Y, but it has to be negated. That's with a bar over it. So it turns out that Z, which is the final output, is simply formed by a AND gate, and according to AND gate, the result are to multiply each other. So let's substitute. So that should be AB multiplied by M plus N. then multiply by x plus y bar. And this is the final answer to this problem as well. Hopefully you find this content interesting and helpful. If you haven't subscribed to my channel, please do subscribe to my channel. Thanks for watching. See you guys in the next video. However, I have an exercise for you, which is very, very interesting. I believe you are going to enjoy that. Please, if you haven't subscribed, like I said earlier, please do subscribe to my channel to help me reach a lot more viewers. Alright, this is your exercise. Feel free to comment your solution in the comment section below for review. I'm going to respond to you if your solution is right or not. So you provide the solution to Z, assuming Z is the final output here, and also provide the solution for Z as well. Okay, let me use another one that said Y. And finally, provide the solution to Q. And let me know your view to the problems. Bye for now.